All right, I'll not bother with the intro and just get right to the point because I'm going to talk to a physicist and their attention span, their I'm smarter than you arrogant syndrome is so compelling and destructive to their function that you can't, you get this tiny little piece of time that you can talk to them and that's it before they just dismiss and run away. So anyway, no offense, Paul, but yeah, that's all it is. Anyway, all right. I am in email communication with Paul Nord, and he's making the cliche argument. Sorry, but they are cliche from my perspective. They've been over and over this kind of stuff. So they have a formula called MGH, and they think this is somehow connected to reality in some way, like it defines energy. Now, I could give you the obvious example where it doesn't mean a thing, and that is you're a spaceship traveling the universe. You encounter a gravitational body. You're going to fly by. Obviously, the H part, that is the amount of distance you'll be interacting with the gravity, isn't going to have anything to do with how much gravity you're going to be affected by. You're going to collect a lot more gravitational force if you go slow and a lot less if you go fast. So the real formula is mgt. Time is the only thing that matters. It's 9.8 meters per 1 second. Every 1 second, you get a boost. Okay, and you get the same boost every 1 second. Okay, so you get the same amount of energy every 1 second. All right, so here's the cliche experiment. Pulling over a pulley, and they drop a weight. And so what they claim is that this MGH, this height, is always the same work. So they're basically saying that if you lift this battery really slowly, you don't do more work than if you lift it quickly. That the gravity is exactly the same. The same amount of gravity was defeated, and therefore it doesn't matter how fast you go, right? So it's completely anti my analogy to rain. So if I consider this a bucket and I'm going to collect gravity as a force, obviously the slower I go, the more gravitational force I'm collecting in the bucket. And obviously the quicker I go, the less gravitational force I'm going to collect in the bucket. Same for going down. Okay, so the idea is they drop a weight and they say this force is exactly the same no matter how fast that weight drops. So you know that if this weight, this mass is high, okay, high mass, big mass, that this will drop very slowly. And so it'll be sitting there in the gravity. And it's not being held up by the ground. It's being held up by the mass. So this mass is feeling every second or every millisecond, you could argue, it's feeling the force of gravity, and it comes out to 9.8 meters of acceleration. The force would accelerate you 9.8 meters if you were able to be accelerated, but obviously you're not because you're tied by a string to the mass. So the mass is essentially holding up your weight. Now you're not going to weigh as much as you would weigh if there was a spring measuring your weight, because obviously you're still falling a little bit. So the force on this string will not be the full force of your mass. But the slower it goes, the more it will weigh your actual weight. The more this force will be, say if you weigh 100, say if this is 150 pounds, okay, the slower it goes, the closer this force will be to 150. And the faster it falls, the less it will be close to that. And it'll get lighter and lighter, smaller, smaller. So the faster it falls, the less energy the object gets. The slower it falls, the more energy goes into the object. So obviously, the heavy mass collects a lot of energy. A very light mass will collect very little energy. That's the truth. Okay, everything I just said there are absolute facts. Okay, that it's going to be completely controlled by the time it takes it to fall. The longer it takes it to hit the ground, the more force was put on the wire, on the string, the more force the object being moved collected. And the faster, so this is like the spring argument. The spring can't give the fast motion as efficiently as it can give the slow motion, except this is the spring on steroids, in the sense that there'll be a huge amount of difference between how much energy you collect if I put a little piece of styrofoam on here, all it's going to collect is the free fall energy, velocity of the mass, and it can't get anything more than the free fall velocity. But if I put a heavy mass on, it's going to get a constant force of the full weight falling in gravity, but it's not really falling. It's falling so slowly. So it's going to get, 150 pounds will be, say, 130 pounds of constant pressure every second, pulling on something, pushing on it. So it's going to get a huge amount of energy. So doing this, okay, I just say on its face is nonsensical, because we all know from our own experience that if I take a year to lift this pen, I'm going to do a lot of work. And if I take a millisecond to lift it, I'm going to do very little work. And that's an absolute fact. Speed matters. The faster you get a rocket to its orbiting velocity, the less energy you'll need, the less rocket fuel you'll need. Absolute fact. So if it wasn't for the friction of the atmosphere, we would get things up to speed immediately, because there's just a huge advantage to, getting through the meaningful gravity, the gravity pushing you into the ground, right? Your orbital gravity is fine because your velocity is taking care of it for you. But until you get there, you have to fight the fact that your ship weighs, and you have to lift the weight to a position. And the faster you get it to that position, just like a weightlifter, the faster you can get it to some other place, the less work you're going to do. It's just an absolute fact, because you're collecting gravity in units of time. It's a time-dependent force. Now, I shouldn't have to say this to professors, right? 9.8 meters per second. Okay, that's just how you measure velocity, so that's just a gimmick. Over 1 second. Not seconds, not seconds squared, not second per second, not any of that nonsense. Every 1 second, that's all you get. It's a time-dependent force. Okay, so I'll just reiterate that point. So anyways, he's using this argument to tell me kinetic energy is real, and kind of ignoring all of my arguments why it's not. So he's not going to show me it taking 5 times the fuel to go 5 times 20. It's not going to take 25 times the fuel to go 5 times as fast. And he's not going to show me something going 5 times as fast doing 25 times the work. So he's not going to show me any real evidence. They just keep doing this instead. Okay, this MGH thing. So it's another sacred Holy Ghost. This is the something angel or something. This is some, what do you call those special spirits? This is the holy Saint Michael or something. No, it's wrong. All right, so that's to Paul. Thanks, but frankly, you keep treating me as if I'm an idiot. All right, so I'm not. So you should assume that I'm making fair arguments, and you're just pretending they're not fair arguments. And it's really, I have a right to be offended, I think. But whatever. We'll just play along. So let's understand. I'm just trying to keep it civil here, but he's also defending Steve Boll's argument that levers don't conserve momentum. So we're going to play the clip from Steve's video. And he's claiming that the rocket does more work, and that's why it still goes twice as fast, but the rocket does more work. So he's sort of saying that we're going to do a lever where we have something that can give a different amount of energy. We're not just dropping something. We're not just placing something on the lever. That somehow we're creating something that has variable amounts of energy that it can produce. And I don't even think Steve implied that. So, but he's clearly saying that levers don't conserve momentum. They conserve kinetic energy. And no, they don't. It's just, I find it amazing. Again, the simplest way to say this is that I haven't seen a single professor admit, okay, they really say it. They just say, it doesn't matter how fast I lift this. I'll do exactly the same work. That's they really say, if I'm holding it still, no work at all. But if I move it, it doesn't matter how fast I move it. It makes no difference to how much work I'll have to do. Which, again, you know, they've got to be able to detect there's a problem. You know, they've got to think, okay, something's wrong with that theory, because that doesn't make any sense. 25 times the fuel to go 5 times as fast. They've got to be able to say, yeah, I really don't think that's how it works. I really have to figure out why does my physics saying something that really can't be true. It takes 25 times the electricity to spin a motor 5 times as fast. No way. So that was for Paul. And then we'll get back to the... Now I might be rude. I'm just asking him to watch that segment that I just did and explain where there's a mistake here. All right, so while I'm here, I just wanted to fix my analogy from the other day where I was trying to explain, okay, this is a lever being suspended from the top. So I want to just show you the simple reason why it oscillates. And if I put the fulcrum in the center, a bearing, it doesn't oscillate. And why at the bottom, it will never oscillate. Okay. So the reason why it oscillates when you suspend it from above the masses is this. So I have to remember to keep this firm. Okay, this has to, the top has to stay in the same position. Now you can see, look how much mass is on one side and how much mass is on the other side. So you can understand that's what's happening when the lever oscillates, is that it's transferring the mass to the side up. Okay, which means the side that seems like it's lighter is the side that's getting heavier. And that's the catch. That's why it works as an oscillator, is because this center line is getting longer. You could also argue the center line, the center of mass line, is getting longer. In a sense, the masses are actually becoming further away, which makes them heavier by weight, not mass. But anyway, that's why it oscillates, is because the thing with the energy is having its energy diluted by the fact that as it applies its energy, more mass is put on that side to eliminate its advantage and take it away. And then it goes back down because the one side gets much heavier than the other side and therefore has to go down. And then it overshoots again, does the same thing. And that's why it oscillates. It doesn't oscillate because of the stupid masses. It oscillates because the center of mass pushes matter to the either side, completely inverse to the motion. All right, I think that's a good enough explanation. All right, back. So it'd be nice if Paul was still listening, if he was listening at all, but we'll see, because this is another point he made. And so the first point I want to make is, again, this isn't a perfect illustration. So you have to go more by what Steve says than what Steve draws. But obviously, these two levers, if you were going to do this simulation, so I don't know whose fault the simulation is. If you're going to do it right, yeah, that's not very good. It's good enough, though. The point would be is both levers should be exactly, I really should be able to do better than that, right? Both levers should be the same length. That would be logical. You want to make the lever irrelevant. And the theory of the lever, that is the law of the lever, is basically doing this experiment, the lever moves exactly the same. So all of the energy in the lever is exactly the same. That's why the force is going to feel the same. That's why it's all going to be the same. It's because the lever is going to move exactly the same in both circumstances. So you've eliminated that variable as an influence, and you just have the masses as added energy to push. And the clear argument is that moving a half mass twice the velocity is exactly the same energy as moving the full mass one velocity. That's the law of the lever. That's what they're saying doesn't happen. Okay, and I'm saying it's just terrible physics. Archimedes destroyed that argument. Archimedes settled that issue. This is settled 2,000 years ago. It doesn't need to be re-argued. The law of the lever is solid. And here they are saying, no, levers don't work. There's something I should be stunned and amazed. Okay. that this is what they're actually arguing. That doesn't matter how fast I lift something, it's exactly the same work. I could hold something in my hand for a year, and they say that I did exactly the same work as if I held it for a day. That's what their physics says is the truth. And you people, somebody needs to say, oh, wait a minute, I get it. That doesn't make any sense. That's all you have to do. Just say the words. That doesn't make any sense. All right, anyway, really sorry. All right, so the other issue that's going to come up is they're going to start, these little rockets are going to start having little flames popping out of their butts. Let's see, come on. Yeah, out of here. All right, and so the argument that Paul's making is that obviously if that was doing the moving, this animation sort of will show that the rocket is applying energy for a longer period of time. But it can't apply the energy a longer period of time, okay, in terms of adding more energy, if the half mass isn't moving faster. It has to move twice the speed. And if it moves twice the speed, then the rocket can't take twice the time. You get it? If the lever moves slower, then the rocket can't move slower. So that theory is completely blow-upable. It doesn't mean anything. All right, so I'll just illustrate that when we get to that point in the video. All right, so he's basically making they're both arguing that levers don't conserve momentum. They don't convert mv, big M, little v, into big V, little m. They don't do it at all, let alone almost perfectly efficiently. They don't do it at all. And the higher I make the difference, 1 to 4, I'm losing over 50% of the momentum. 1 to 10, I'm down to like whatever, 10%. Okay. So leave this, hit the required button.
Meter, well, it takes longer in the case of the ½ kilogram that's twice as far from the pivot. In other words, it acts.
So it takes longer, but it can't apply more energy. He's arguing that only 1 joule of energy goes in. So taking longer doesn't make any difference to how much energy went in. And certainly if you're arguing it does, then you have to apply more energy. And if you applied more energy, then it has to go slower. So the rocket can't push longer and the object moves slower. You get it? The rocket can't move slower and also the projectile moves slower. If the rocket moves slower and applies more energy, then the object has to move faster. It can't move slower. It's not possible.
Accelerates more slowly and the velocity at the end is lower than my intuition would have expected. To wrap it up mathematically.
Right, so to wrap it up as nonsense with no experimental evidence. So let's again just proclaim the truth. Let's not show the truth. So again, just part of the religious catechism, the catechism of physics. You must believe in the Holy Ghost. You must make acknowledgement to him with the proper signaling. You must, bow to his authority. The authority of absolute made-up rubbish equations.
We can ask the question, well, how much slower will it be going? Well, we know that the energy must be 1 joule, and then you can derive what the velocity must be.
So he's saying it's 1 joule no matter how fast or slow it moves. Okay, so what does that mean? How can that mean anything? I mean, it doesn't make much sense is all I'm saying. 1 joule applied slowly means you've lost a whole bunch of energy if the object moves slower. You're not gaining anything. You get it? You're saying it's taking more time to apply the 1 joule, but the object isn't getting it. So what are you arguing?
But if we're trying to disprove the free energy hypothesis, we should probably prove that the ½ kilogram.
So they don't prove anything. We should probably prove. He says those words, they don't prove anything. So there's absolutely no evidence, no proof, no logic, no reasoning, nothing. Just a statement that we believe it and you should too. We're Peppers, Holy Ghosters. We're Holy Ghosters. You should be a Holy Ghoster too. So I should write the song.
mass has a kinetic energy of 1 joule from a force perspective first, which
There, so he's saying it. It's 1 joule, 1 joule.
is actually really easy. The key is to notice that the force
See, the key is to notice that the rocket was on longer and the object's moving slower, which makes no sense. Yeah, that's right. You got less energy into it with more rocket fuel.
on the half kilogram mass is half a newton, because
So if it went twice the speed because you added more fuel, well, then you can't add more fuel because the rocket won't be on longer. You get it? You should be able to get it.
that's how mechanical advantage works. From the work
So this is how mechanical advantage works, right? There's no such thing as a mechanical advantage. There's just a conversion of momentum. And that's all there is. And they're never going to prove to you there's any whatever scalar energy increase magical stuff. Okay? They're never going to show you it taking 5 times the fuel to spin a motor 25 times the fuel to spin a motor 5 times as fast. It's never going to be shown because it doesn't happen, because it's nonsense. It's not real science. It's not real physics.
equation, we get half a newton times 2 meters is 1 joule. You then get the velocity by rearranging the kinetic energy equation. And when you do that, you find that whatever the final velocity of the
So again, if I change this scenario to some other scenario with a higher differential, quarter mass, I'm down to 30% of the momentum. I've lost 60%. I mean, it just gets worse and worse. The bigger the ratio, the more momentum you lose. So Archimedes was full of nonsense to think that somehow you could move anything with a lever, because you lose so much momentum.
the larger mass was the smaller mass, instead of being double the velocity, it's root 2.
Right. So you put in more energy and you got even less velocity. Yeah. So that makes sense to somebody? No. So right in this example, he's arguing that 30% of the momentum, with just a 2-to-1 relationship, 30% of the momentum is gone. He's not going to explain where it went. It's gone. It's just a fact. Where is it?
Times the velocity of the larger mass. So that's where my intuition went wrong. These two spaceships...
So again, he's claiming it's his intuition. He's setting up this straw man argument in the first half of the video, pretending that, yes, I understand that levers conserve momentum. The thing leaves with twice the velocity because there's obviously half the mass. You're going to be able to put twice the velocity, no problem. You can throw an 8-pound bowling ball twice as fast as the 16-pound ball. There's no laws against it. You're not going to lose 30% of the momentum if you pick up the 8-pound ball. These are all notions they put in people's heads that have no physical evidence to support them. There's no evidence that's true. Again, we landed on the moon using momentum to measure thrust, not measuring kinetic energy. So again, it's just, they're totally oblivious and belligerently hostile, okay, to accepting this is an incomplete theory, as physicists say. This is incomplete theory. It doesn't make any sense. You can't do more work on the lever and get less energy out, less momentum out. Not possible.
These two different scenarios don't have identical experiences. One of them moves more slowly.
So that's his argument. So I can't set up a lever where the lever moves the same speed to move a half mass at twice the velocity, saying that can't happen, and they have no experimental evidence demonstrating that's true, that levers don't work, that levers can't conserve momentum. No evidence whatsoever. And I shouldn't be the only one pointing out that that is abysmal science. When you can't support your argument with credible evidence, it's garbage as science. It's a religion. All right, just to emphasize how bad this science is, in the very video he's making, he puts in this minute physics clip that basically asserts that pulleys certainly do conserve momentum, okay? They absolutely conserve the momentum. The half mass will move at twice the velocity with the same force applied. So they're making both arguments in the video. So this is their nonsense of we can conserve both the momentum and the kinetic energy as long as you allow us to cheat all over the place. You know, it's just so, it's so bad.
inertia, or whatever the equivalent of that is.
Yeah, whatever the equivalent of inertia is, because we just made that up too. That's a term we use. It doesn't mean anything. It isn't hard to push things. You just have to give them energy. Yes, homeless people will accept your $10. You just have to hand it to them and they will accept it. They're not resisting. And mass doesn't resist velocity. It just says you have to give me a force or I'm not going anywhere. So you actually have to give it to me. There is no resistance to motion.
pulleys. And you can also contrive a similar but not exactly the same situation with inclined planes. So I think this whole puzzle...
Okay, so this isn't the part where he moves the... Oh, there's the moving part. Okay, so I missed the moving part. Let's get to the
You could hold up a 1 kilogram object with a rope over a pulley like this, or a 0.5 kilogram object with a pulley set up like this.
Now watch this part where he says everything too fast. But you just watch this part. The little 5, the half mass is going to go twice the distance in exactly the same time. Meaning it's going twice the velocity. Meaning it's not going 1.4.
And the force you'd experience would be the same.
It's not square root of 2. So he's saying 10 newtons on both sides. Do you see the 10 newtons on both sides? Do you see 10 newtons? 10 newtons, the exact same force. The two ropes that they're pulling could be tied together and they pull. And those are the results exactly as you're going to get them. You're going to get the half mass going twice the velocity and the one mass going 1 unit of velocity. That's what's going to happen. This is an argument he's making in his own video. His own video is debunking his video and nobody notices? No one? Trumpocracy.
For you to pause and think about.
I'll just blame it on Trump. Everybody is insipidly stupid.
For you to pull your rope
There, twice the distance in the same time, twice the velocity, no problem. Same force, twice the velocity, no problem. No broken. So somehow pulleys aren't broken, but levers are broken. Pulleys conserve energy in violation of kinetic energy theory, but levers do not conserve momentum in violation of kinetic energy theory. I mean, it's just such obvious, duplicitous, hypocritical crap and has no logical foundation. It's not a reasonable argument. It is garbage as it's a thought crime. It's saying 2 + 2 = 3. It is so frickin' idiotic. And here I'm the only one making a video saying this is bullshit. And again, Paul, the only other guy who made a video on the subject, he agrees with this crap. He thinks that levers don't conserve momentum because they must conserve kinetic energy. Sorry to be mocking. I just can't. There's no way to have this argument in any other context but to accept you're the arrogant dogmatists. I'm not the trolling physics crank. Okay, you're ivory tower obnoxious authorities who are naked emperors. Okay, you've showed no credibility. You've thought about this 0 amount of time. Okay, so it's not 9.8 seconds for... No, you haven't thought about it, a billionth of a second in any kind of honest way and recognized this theory is crap. All right. See if there's anything else I want to throw in this video. It's probably enough. I'm just trying to think if there's anything else Paul argued that I should grab while I'm here in case he's watching like I said, you can't get them to watch any physics videos. No way. They can't be educated, because they really are so full of themselves. I have a degree. Fuck you. Yeah, no, it doesn't work that way. Lots of people have graduated with degrees that don't mean anything. Anyway. All right, pause. So, sorry for my kind of hostility and whatnot, but this is a ludicrous circumstance. I mean, intelligent people should be all able to acknowledge that 25 times the fuel for 5 times the motion doesn't sound right. They should be able to say that's violating intuition in some kind of major way. I mean, monstrous way. I mean, that's like, somebody with the screen name Big Dick, and what's the chances that he has a big dick? Yeah, no chance. It doesn't make any sense. It doesn't fit. It doesn't in any way is this a reasonable statement. And anytime you say some basic tool does not conserve momentum, you know that's got to be something in your brain that says, no, that really can't be true, because, momentum is solid. Momentum's heavy. It's got substance. You can't just poof it out of existence. You have to explain where it is. If the lever doesn't work, where did the energy go? Where did the momentum go? And then this whole I say so thing, right? You really think that's how it works? They should just be able to I say so? They shouldn't have to show you anything? No car crashes, no nothing. No experiments actually showing this kinetic energy stuff doing work. No evidence that a rocket, here's so much thrust I'm going to shoot out of the rocket. I got some gas, I'm going to shoot it out at a certain speed. Let's calculate the kinetic energy and see how much the rocket moves. Right? We know that this ain't going to work. The kinetic energy isn't going to move the rocket. The momentum's going to move the rocket. I have to make this argument to intelligent people over and over and over again. Yes, it's a ludicrous circumstance. This is ludicrous. This is Star Wars science. It's just bullshit. I mean, it's just bullshit that I'm on a planet with people that have all this neural capacity, doing all their little equations, all this bullshit, and I have to explain to them that this crap they're spewing doesn't make any goddamn sense. Like I said, in the very same video, he proves two things. He proves that pulleys work and conserve momentum, and then he proves that levers fail and don't, when the two objects are essentially the same machine. Just amazing. So yes, I'm hostile because I should feel defensive and afraid to exist on a planet of people this frickin' stupid and dishonest and treacherous.